So we're giving this talk the first time, so bear with us. We're gonna try to wrap everything up in the end in case we forget something. And like Eric already said, please post your questions so we can have an engaging Q&A in the end. That would be awesome. So first, quickly about the two of us. We've been introduced already, so there's not much to say other than our role in this project maybe, which we'll get into during this talk. I was mostly responsible for managing the whole project itself, kind of like a product ownership, if you will, and managing all of the processes. And Jonathan was responsible for all things technical. So he's the architect behind the solution, basically. And yeah, that's also how we're going to cover the topics in the talk. So we're going to be changing back and forth between the two of us to cover all the topics, being it more about the process and the project or more about the technical deep dive, which we'll get into. Cool. So first thing, maybe very briefly about us. We've heard the name JOSHMARTIN. That's our small company. We've been in the field for 6 years. We specialize in business automation on the web platform. So the web really is our jam, so to speak. And we focus on 3 industries mainly, and that is finance, insurance, and medical. So that's also where the contact tracing topic really comes from. We're 7 people and we're based in St. Gallen, which is in the eastern German-speaking part of Switzerland. Cool, so what are we gonna cover in this talk? We're gonna start with a very brief intro of what contact tracing actually is. Nowadays, most of you probably know a lot about the topic, like all of us do, because we're still in the midst going towards hopefully the end of a pandemic. So it's been really a public facing issue. So we're not going to lose too much time on that, but just to give our perspective on the topic, maybe briefly. We're going to talk about the project challenges that we faced. We're going to talk about where we started from a technical perspective, how we came to a first release of the software, and the process that followed after, some technical challenges, and this will be the technical deep dive that I'm sure you're all eager to hear about. And we're gonna wrap it up by telling you where we stand today and how we see the future potentially. Good. So what is contact tracing? Essentially, contact tracing is about finding the link. So the link, what do we mean by the link? The link is a connection between people that have interacted with the disease in some way. So this could be what we call an index case, which is somebody that is positively tested for the disease, or a possible index case, which we all know by the term contact person, usually in some way. So these links are incoming and outgoing, and that is very important to understand. Good. Now, why do we conclude contact tracing? First and foremost, it's about stopping the spread of the virus. I'm sure everybody has had their own experience with it somehow at this point. So it's about confining potential spreaders of the disease. It's also about assessing the situation. So how contact tracing is performing and the data that is coming out of it is very important for health officials to make decisions. It's a very important key factor in assessing the situation. And when we assess the situation, obviously there are a lot of decisions to be made. I'm sure we're joining here from many countries, many continents, even hopefully. And these decisions have been very different in different places. So obviously contact tracing is only one factor that goes into that. There are political aspects, there are social aspects, but it's one key factor in most places. It's also about informing the public and informing individuals about how they will be confined, for example. So that's also a part of what we do in the contact tracing process. Now, how do we do that? We do that with a team. So there's been lots of discussions, you know, can you fully automate contact tracing? The decision here has been made that we can't really do that in full. I mean, we tried really hard, you know, and you're going to see how we tried, but it's something that still needs people. The second thing is data. Data is very important, as you can imagine. It's a very complex topic, and you need to really think about which data to track and which data to discard. It's about the process mostly. So procedural thinking in designing these solutions really, really helps because it's incredibly complex otherwise. And also it's about tooling. So we decided to have a distributed team in tracing. So from times over 100 people in many different places were tracing from home, from an office. So tooling is very, very vital, especially if you think about the processes, data aggregation, etc. So first thing, team. This is a little screenshot. You're just going to encounter some of those. Thinking about a team is thinking about who does what and when, and how important is it, and what's the current stage. So this is not really about the data itself, but about the team that really uses the data. Second thing is the data. So if you aggregate data, it's very interesting to make data accessible. By the way, the data here might be skewed a bit because it's from a testing system, so it's not real data, just in case you wonder about the strange curves that it takes. So making the data accessible for these decision makers is very important as well. And what I mentioned previously is the procedural thinking. So many of these cases, like for example, how do I find out which people I had contact with and where, and how intense was the contact? Was it protected or not? Data of these people that I had contact with, etc. If you put that all in one process, it's in a lot of data. It would be a huge form that you would present people. What you see here is a process that we came up with for index people, so people that are confirmed COVID cases, to submit their own contact persons. And doing that, we saw that we need so much data. It's really important for these people to, because they're mostly laymen out in the public, to guide them through that process. And you can do that with software, and that's amazing. And the last thing is the tooling. As you can imagine, confining people during having to quarantine and then maybe getting a positive test result and having to do isolation is, again, really complex. Now, if you hand it over to every single person working in tracing, you're going to have 5,000 different solutions of how to handle that. So the job of the tooling here, and that's the core, right? That's what we built, was to really build a solution that helps with managing the complexity of the data. And I would really like to discuss with you everything you see here, but we're already running out of time, so I really have to continue. Good. Quickly, what does contact tracing mean in terms of COVID? It's a lung disease, right? It's airborne. It has a certain incubation period, which might change even, or did change statistically with mutations. We have symptoms. We have the timing of the disease. So when everything gets together. And for us in Switzerland, that meant we basically really adjusted ourselves to what the Federal Office of Public Health put out. So we really try to be as close as possible on the public information. Good. Very quickly about project challenges that we identified very early on. First one is communication, right? It's very key. Communication is key, one in the project or in the contact tracing process, because we need to communicate with a lot of individuals over lots of different channels. Mostly this was done by telephone here, but also via SMS, via email. So there's like lots of communication, and also internally, because we communicated a lot with the public officials, for example, that manage this project. So this is really, really key. The second thing I already touched upon already was data aggregation. So there was, if you can think of every potential data point, you can come up with thousands, but you can't manage all of them. So aggregating the right data is really, really important. Information security, as you can imagine, this is health information, so it's really, really vital to protect it, to manage access very strictly. And you also have, usually, at least here in Switzerland, you have a lot of legal regulations that apply. Velocity and agility, because the situation already changed. I know back then we started developing it, and 2 weeks after, things were already different. So maintaining agility was very, very, very important as well, and very challenging, and still is. Like I said, it's incredibly complex, but we also needed to be efficient. So walking this tightrope between managing a very complex topic and staying efficient and getting the right pace was also a challenge. And when we started developing the system, it was needed yesterday. So they wanted to have it now. So that's another challenge we faced. So I'm going to hand over to Johnny, and he's going to get into the technical origin.
We've decided to build this system based on the default JOSHMARTIN technology stack, which is using Elixir, ecto, and Phoenix. And we're deploying the application via Kubernetes. So we're using a standard mix release and Docker build, and deploy that via Helm to the Kubernetes cluster. The cluster in this case is a dedicated cluster by a provider in Switzerland. Again, for data protection, we kind of needed everything to be located in Switzerland. And for the first time, we've also decided to use Phoenix LiveView and Surface. The reason that we use Phoenix LiveView in this project is that it allowed us to iterate quite quickly, and it removes the boundary between the front end and the back end that we normally do with like a single page application in the front end and API. And yeah, therefore we can improve the velocity. The downside on this is with the standard approach that we normally do with the API and the SPA is that we get an API for free, basically. In this case, we have to maintain an API on the side for just all the relevant parts that someone else wants to consume. And we've decided to use Surface for the reason that we have front-end engineers here in the company that are normally used to work with Vue.js and JSX. And Surface just is more approachable from that mindset, just because it looks more familiar. To ensure code quality, we're using Credo, including a few non-default specs. For example, we're enforcing dialyzer specs for most public functions. We're using dialyzer quite extensively to analyze our code, and just the defaults like XUnit and mix format, just to make sure it works well. And yeah, for the data governance, the health data really needs good protection, and it therefore must never leave Switzerland. So that also removed the possibility to use software as a service products, like, for example, Postmark for sending emails, just because it's not located in Switzerland, and most of them are not. Yeah, so about the initial release. So we did our first release just 1 month after we've actually started developing the project, and we used 3 developers internally, 2 backend, 1 front end, and 1 project manager. The adoption was quite fast, so we migrated from the old Trello-based system to the application in less than 3 days. There was a huge anticipation from the tracing side, to actually get started in a tool that actually helps them do their job. And there was a huge backlog that built up based on the old solution, and we were able to reduce that quite quickly. When we started, we also were at the point where there was a lot of cases. In our region, that means we had around 400 new index cases. That means positively tested people per day. And we had around 10,000 cases. That includes index cases and also the contact person cases per month. The tracing team at the time was over 100 daily users. Now I'm going to give it back to you.
Thank you. Good. So what happened after, right? We released, and what that set in motion was a process that we tend to only think about when it really sets in motion, which is what happens after the release, right? And that's something I want to really touch on briefly, because we found out it's very, very important, especially in a highly dynamic field when you don't have a release window of a year and you have time to work everything out before you go. So we were kind of hit by this reality because we were so focused on getting the software out as fast as possible. So what happened after, right? We made it available. And what we did from the very beginning is we tried to make video guides and written guides to support users in actually using it. Because as you can imagine, we couldn't lay down the work of tracing and just have a week of let's try the new software, everybody, and let's do some trainings. They basically had to hit the ground running, right? Very soon we realized we're not gonna get around user training because it's just too complex of a topic. So that happened like almost instantly, and we started doing that. And that's mostly because these people were medical professionals in our tracing teams mostly, but they were not used to using software like the one we built. They were used to using Excel and things like that, and paper even to do their work. Also, we realized if we want to keep up the high pace, we need to test new releases. And as I'm sure most of you know, concise testing and testing reporting is something that is kind of an art, really, as we see it that way at least. Because we've all had our fair share of bad bug reports that do nothing really at all. So the expectation was still a very high release pace and a lot of stability. So we all know this is quite the conflict you have. So the next thing we tried to do is we came up with this concept of a super user. So these were people that were in the tracing team, that were professionals, that were very familiar with the process. And we tried training them specifically in our field as somebody that understands enough about the system itself and how it's built, but also understands the tracing process and bridges that gap really in between what we need to have as a team developing the software and what tracing needs to do. So we improved greatly on testing quality after that. The workload of supporting users was taken off our backs because we were focusing on developing the software, and very simple questions could be answered by these super users. So that's a concept that really, really played out well. And authorization, because we do have some tasks that are more delicate in terms of information security. So we don't want to make them accessible to everybody in the team. So we built this like core team of super users and handed them over some of the delicate tasks. And then we started incorporating a Kanban process together with the super user that was also publicly accessible for the team. So everybody could, if they wanted, look at what's going on, you know, what bug reports do we have open, what features are coming, what's the release notes of the last release. And the super users were key in maintaining that and making it accessible for the general users. And then we started increasing the pace more and more and more and more. And what happened then, obviously, is we faced a lot of technical challenges, which Johnny is now going to get into.
Yeah, so about the technical challenges, as we said, we used Phoenix LiveView for the first time. And one situation that we encountered was that we built a search component that searches through various places in the system. And to speed up that search, we needed to parallelize that search. And we also didn't want to block the view while some longer running queries were running. So we actually had to do that asynchronously. At the time when we encountered this, the problem was that components do not have their own process, and send update, which works with components, does not work if you call it from outside the current process. To solve this, we proposed to add an optional pit parameter to the send update function via the Phoenix mailing list, which also worked. So the key takeaway here is you can easily extend the library like that. You just need to interact with the maintainers and find a good solution. A second problem that we faced also with LiveView was the encapsulation and communication between LiveViews and components. We were gradually building more complex components. For example, we had something that was a simple select at the start, but later got extended into like a chooser kind of modal since it got too much data in there. And then later on, we also wanted to support the case that you can actually create or select entries via that modal. And to do that, we would have needed to use messages and actually convert this to a live view. But a live view does work fundamentally different from how a component works. For example, I am not able to provide parameters to a live view the same. They're going to be sent via the browser and therefore are serialized and unserialized and untrusted. So I cannot pass something like some things like pits or functions or stuff like that. And also the parameters of a live view, they can't change except for routings because the handle params hook only works for routing. And this is still an ongoing problem. Actually, this is currently unsolved. There's an issue open at the mailing list. Actually, it would be great if you could chime in there if you have any ideas how to solve this. In my opinion, there's two solutions. Solution one would be to actually open up the APIs from LiveView so that it can be extended with like a custom layer on top that handles this, or to use some inspiration from like existing front-end frameworks like Vue.js or React or something like that to build like an opinionated data flow so that those use cases can be supported by LiveView directly. One other problem we ran into was versioning with ecto. So all data that we have in the system, we need to make sure that we always know who changed what and when. And for that reason, we chose an Elixir library that actually does this job. The problem with it was that it doesn't really support repo all functions, so it cannot insert multiple things at the same time or delete multiple things at the same time. And it also doesn't support any automatic changes from the database itself. So for example, a column being set to null because a referenced row is deleted. To solve this problem, we've replaced the Elixir library with Postgres triggers, and we set the author information via local session variables. A key takeaway from this one is that Postgres is quite powerful, and it might make sense to actually not invest in a library in the language you're using, but instead actually do it in the database itself and leverage what it can do. One other problem we faced was a bad design decision made by us with embeds. We were trying to group some entities together so that they're easier to see in like the version history. So that's why we decided not to put them in multiple rows. But JSON fields do not really support foreign keys. And as the data model grew, we actually had to add some foreign keys to those models, which we didn't had to at the start. And that actually gives the problem that we can produce stale data. So we can have, for example, an ID that references a row that no longer exists, which can lead to 404 errors. And the solution to that is just to work on the problem the other way around. We have to work on actually presenting the data in the history nicer and not try to denormalize the data to support that. And that's also what we're doing. So basically we're normalizing all the things that we should have done from the start. Yeah. We've also been in the situation that we need to send emails to a lot of our people being traced. So for example, to order them to quarantine, but also we need to send emails to our workers and to tell them like you have a new notification. And those emails have to come from an official address from the region here. This is so people don't doubt the authenticity of those messages because I mean, they're being ordered to stay at home. And the problem that we faced was that the tenants that use the system were not able to provide us with SMTP servers, since they're only exposing their internal networks, where we're not in, and they were not able to expose those. And we also couldn't use SMTP as a service because we couldn't really find a good provider that is based in Switzerland. To solve this, we've decided to actually send the emails ourselves using GenSMTP. GenSMTP is quite a cool library, but it only provides the low-level functions. So it does not provide you with a spooling mechanism, which you should do with emails. And therefore, we've implemented our own spooling mechanism, also based on ecto and Postgres with row locking. I was a little scared from the start that this might be a problem, since emails are a lot around reputation. In fact, we were able to build a quite high reputation very quickly, which surprised me. It's just important to think of SPF and reverse pointers and DKIM to just make sure that those emails are rated as good as possible, so you can quickly build that reputation. And also really important is to never ever send emails multiple times if you have some internal crash. Otherwise, your users will get quite angry at you. Yeah. Error reporting. Since all the infrastructure that we were using was effectively provided by us and the partner company, we're not relying on any third-party services. We did not have an error reporting and collecting service from the start. And we've had the issue that we got reported bugs that were quite hard to reproduce since we didn't have any stack traces or something around it. And grabbing through Kubernetes logs is just quite tedious. And we were also sometimes unaware of background job errors that happened just because from the surface it looked like it worked. The solution to that is to set up an error collector. In our case, we set up Sentry. And we actually fixed quite a lot of bugs that we were not aware of until this point, and therefore also improved the general stability of the system. So in my opinion, it's quite important, even when you're under extreme time pressure, to not go lazy on this part and actually set up something for that from the start. I'm actually going to skip that because of time. The last one I want to talk about is OTP supervision. We've accumulated quite a few background jobs over time. So those are automated emails and data synchronization and export to the federal government and statistics that were refreshed, etc. And we've just added all those jobs to the main supervisor of the application. The problem that we faced is, especially since a lot of those jobs have external dependencies, if those dependencies were down, they would produce repeated crashes, which then would in turn bring down our supervisor and the whole application. To solve this, we've created some extra supervisors for those jobs and also tweaked their settings. And we've tried to, especially in the case of external dependencies, to really see how they could fail and incorporate this in our code, so that if we, for example, cannot get ourselves a token from the IAM, that we're also not trying to sync with said IAM and just log an error and skip instead. And yeah, the important part here, in my opinion, is to actually build a supervision tree and not just a supervision list. And to take like the unhappy paths, but which are still expected into account when building this, and not just one happy path.
Thank you. Here I am. So where are we today? And don't worry, Eric, I'm gonna try to rush it a bit. Good. So today, the system has over 60,000 cases, probably even more now in it. So the database has grown. We've had over 185 unique tracing users. Now it takes around 15 minutes to fully trace a COVID case with our system, which used to be around 2 hours before, with all the documentation needs that you needed to fulfill. And we don't have a backlog overflow in cases anymore. So the problem really lies with, do we have enough people to trace, and not, does our system allow us to trace as fast as possible? Some learnings, like Johnny already touched on, we also incorporate a lot of third-party data. This might be, in a lot of cases, bad data, because if you really think on a problem of data, on a fresh piece of paper, you can come up with really nice solution to third-party data, to like your data problems, like how do I maintain quality? But a lot of the systems that you need to interact with in this field are really old systems that were just built over time. You know, we've incorporated a lot of like legacy system data, and we should have thought about that a bit more from the beginning. So for us, it was really about how can we overcome missing data quality from the outside. That was a really big learning for us. The other thing was the ambiguity, what we call plan for ambiguity, or program more strictly. That was kind of the paradigm we took out of that, is because this whole field is so much ever changing all the time. You can either be very strict, or you need to think about where you put ambiguity in place and you allow it specifically. So what is data that is really required, or do you want to really plan for maybe not having that data? So even if you let something be ambiguous, think about what the impact of that ambiguity might be. Hygeia, that's what the software is called. I'm sorry, I think we didn't even mention that. Hygeia is released on GitHub. It's under a cross license or under a BSL license. So you can actually look at the whole program if you want to, and we invite you to. It would be quite cool if people do that. So a lot of organizations could even just use the software. So if another district here in Switzerland decides to use it and not commercialize it, but just use it, they could. So that's what we tried to do. The future, we aim for greater adoption, hopefully, even by not putting it into the too commercialized thing. You know, we want greater adoption because we think it's a very important cause. And we also think about decoupling it from COVID-19, because COVID-19 is really just one medical clinical picture, right? And most of the things in here don't only apply to contact tracing on COVID-19. So that's another thing we were thinking about. And that really concludes it. I think we're over for like 3.5 minutes. I'm sorry, Eric.
I think that's perfectly okay. Thank you, Jay and Joni. This is just amazing. So I want everyone to turn on their cameras and unmute and give a big hand. Let's see if we can give a big virtual hand, not the virtual hand, a real hand. Because what you have just told us about is truly amazing. I mean, seeing how the Beam can do good for society is just, you know, it's just amazing what you have done in such a short while. And seeing the adoption and sharing it back with the community, using the tools of the community, sharing it back with the community. This is what it's all about, you know, sharing, learning, and you know, we beam together. So it's a perfect example of that. So great stuff, amazing. Let's see if we have some questions in the Q&A. I'm gonna go to the Whova app and see what's in there. So I think I have one here from Bartek Borkowski. So Bartek, if you would like to unmute and, you know, ask the question real live, that's more fun than if I'm reading it. Are you still there, Bartek? Don't be shy. Or do you want me to read it? So I'll give you a few more seconds, and the question is...
Okay, sorry, I was unable to unmute until now.
Cool.
So my first question was actually answered within the talk, because I answered it before you said that you used Kanban. So thank you for answering that. But I also asked another question regarding the background jobs, because you said that you had to tweak supervisors and create a supervision tree for that. I was wondering if you considered using Kubernetes, or if I missed that, whatever cloud platform you were using for deployments, to handle that for you, because there are pros and cons of both approaches. I was wondering, why have you chosen this one?
Yeah, there's multiple reasons for that. The first one was just speed. Setting up a lot of Kubernetes jobs is just, yeah, it needs more work than to just add a job to your supervisor. The second reason for it is a lot of those jobs still interact with the rest of the application. For example, if a statistic is refreshed, then the statistics view also refreshes at the same time. So you would also need to cluster the job together with the rest of the application, which is certainly also possible, but makes it more complicated again. And then the last one is we do have quite a lot of dynamic jobs. So for example, we can freely define inside the application at what point in time export to the federal governments are made. And therefore, you would need to reconfigure Kubernetes every time, but like this, I can just check regularly if I need to export something and do it, and actually adhere to that schedule that is configured. But yeah, for a lot of the jobs, that would probably be a good solution to do.
Great, thank you. So we move on. I think Alessio had a question as well. Alessio, would you like to unmute and put forward your question?
Yes, please? Yes, I can. Okay, can you hear me?
If you turn on your video, that's also perfectly okay if you want to.
I don't have a webcam on this PC. So
okay, that's okay.
I'm
that's
sorry,
okay
guys.
as well. Please go, please go.
So you did quite a job with the OTP, and you deployed the application on Kubernetes. How did you match the two of them and create a full-fledged Beam cluster with the Erlang cookie on Kubernetes?
So the cookie is quite simple. We're just generating a random string for each deployment that we're doing, and we set that as a secret in Kubernetes, which then in turn is an environment variable. The more difficult part is to actually find all the other pods and connect them together. So what we're using for that is a combination of libcluster is the name of the lib, I think, which basically can either list pods or endpoints inside of Kubernetes to actually discover other pods around, given a label. And yeah, so basically it just does that, searches for all the pods, does no connect, and that's basically it. Therefore, it works quite simple, I think.
Thank you.
Obviously, with RBAC, you need to set up a service account, so Kubernetes can actually do that. But yeah.
So we have time for the final question that we have, at least that I can see in the Who app, and that's Ngan. Ngan, you want to ask your question?
Yes, can you hear me?
Yes.
My question is related to how your application operate, like who is the main user and when they will use it?
Maybe I can answer that. Finally, one I can answer. So the main users of the application are going to be contact tracers. So these are, in our case, medical professionals that have experience with interacting with patients, which we would consider at least positively tested people. So that's the main use case. We also do have a lot of other user groups. So we have health officials, they're mostly going to look at statistics and numbers inside the system. We're going to have these super users that I talked about before, who are going to be responsible for data quality and quality assurance, for example. And What else do we
The
have?
last group is the person actually being traced,
Yeah,
since we
of course.
generate confirmations for quarantine and isolation that they can actually download there. And also they can submit, the positively tested people can submit the people they might have infected. So there's a little bit of self-service going on, which is also going to be extended in the future, since there's some changes in the regulations here on how people can shorten their quarantine period if they, for example, test negative after some time in that period. So we're going to extend the self-service use cases more, so that basically we don't have to have a professional on our side actually take a call or something to make it happen.
Thank you.